Okay, notes on Chapter 5, Section 2, Properties of Parabolas. Graphing the function of the form y equals ax squared plus c. Notice there's no middle term. The graph of y equals ax squared plus c is a parabola. With an axis of symmetry at x equals 0. The y-axis is the axis of symmetry. And I'm going to use AOS to mean axis of symmetry. Okay, so it is the y-axis that is the axis of symmetry when you have no middle term. The vertex of the graph is the y-intercept 0, c. C for constant, whatever that y value is. You know, like y equals mx plus b. Right there it is. That's your y-intercept, 0, 1 for this example. Because this example is of the form y equals ax squared plus c. So my c value is 1. It's not a y equals mx plus b because this is quadratic, and y equals mx plus b is linear. All right, so our directions are to graph y equals 1/3 x squared plus 1. The very first thing you have to do is find the vertex. So the vertex here, remember, if there's no middle term, it's always 0, whatever the constant is, 1. Then we're going to make a table of values. So here we have x. Here we have the function y equals 1/3 x squared plus 1. And then we're going to calculate our y. We need 3 values. And you're going to choose those values. Well, the first value is going to be the vertex. 0, 1. This one is always the vertex. And then we're going to choose 2 values to the right of the vertex. Choose 2 values to the right of the vertex. We want them to the right because then we're going to use, those are going to be called points P and Q, and we're going to use the axis of symmetry to find P prime and Q prime. So point P and point Q, I'm going to choose, I don't know, I guess I'm just going to pick a 1. Now, I'm not going to pick a 2 because notice, you know, I have to square the 2 and then multiply it by a 1/3. I'm going to choose a 3 instead. Plus, I want my points spread out more. Sometimes the parabolas are pretty small. All right, so when I substitute up into the original function, this is 1/3 times 1 squared plus 1. Well, 1 squared is 1 times 1/3 is 1/3 plus 1 is 1 1/3, or 4/3. Folks, do not give me decimals. Some of you keep doing that. You must give fractions. Thank you. All right, the next one, 1/3, 3 squared plus 1. 3 squared is 9. 1/3 of 9 is 3. Plus 1 is 4. Okay, so these are my ordered pairs that I'm going to plot. 0, 1, 1, 4/3, which is 1 1/3. 3, 4. I'm going to plot those. All right, so why don't we go ahead and do that? The vertex is x is 0, y is 1. Point P is x is 1, y is 1 1/3. That's point P. X is 3, 1, 2, 3. Y is 4, 1, 2, 3, 4. That's point Q. Remember, for these types of problems, the y-axis is the axis of symmetry. So my axis of symmetry is the equation x equals 0. You could, with a different color so you could see it, well, you know, put the dashed line. Can't really see it too good, but I'm just going to draw my arrows. All right, there's my AOS. Since point P is 1 unit to the right of the AOS, P prime would be 1 unit to the left at that same value. 3 units, 3 units. Now I have 5 nice points that I could draw my U-shaped graph. Now this is a smooth graph, and you don't want to go too far past the last point. Let's see if I could do this without turning my paper. All right, parabolas have arrows on the end of the graph, so make sure you're drawing your arrows. Okay, so what did we do? Well, we plotted our ordered pairs, and then we had to find P prime, Q prime, right? This one was P prime, Q prime. We say prime, it's the corresponding point. And we found those by using the AOS, the axis of symmetry. Then we connected our points with a smooth curve. So I don't think there's much new except maybe, you know, choosing 2 points to the right of the vertex point. You have already made tables for graphing. All right, side 2. Now, these problems, or this one here on this page, is graphing a function of the form y equals ax squared plus bx plus c. It's still a parabola because, you know, it's quadratic. So the graph is still called a parabola. When the leading coefficient, the a, okay, we always put our polynomials in standard form with the highest exponent to the lowest exponent, and the leader of the pack is called the leading coefficient. So when the leading coefficient, which we call a, is greater than 0, so when a is greater than 0, which means it's positive, the parabola opens up. Okay, and so opening up looks like this. And since a is positive, typically when you're in a positive mood, you have a smiley face. So there we go, there's our smiley face. When the leading coefficient is less than 0, remember it can't be 0 because then this wouldn't be quadratic. So it's either greater than 0 or less than 0, which means it's negative, then the parabola opens down. And we saw that with absolute value functions. You know, if the leader was negative, the V-shaped graph opened down. Same thing with the parabolas. So this thing is going to open down. And we say the A is negative, and typically when you're in a negative mood, you have a frowny face. Okay, so make that connection. The axis of symmetry is the line x equals negative b over 2a. Okay, and we get our a and our b from the function itself. Okay, so all you have to do is pick up those values. As long as your quadratic is in standard form, you substitute your a in for a and your b in for b. But the x part, x The axis of symmetry is the equation x equals negative b over 2a. The x-coordinate of the vertex is that same thing, negative b over 2a. We saw that in the last lesson, that the axis of symmetry would always be the equation x equals whatever x is in the vertex. So it should make sense that those are the same. The y-coordinate of the vertex is the y value of the function when x is equal to negative b over 2a, or find y equals f of negative b over 2a. It just simply means once you find the x, you're going to substitute it back in here and calculate the y. Right? Remember when we found f of 2, we put a 2 in for the x's to find the y. Same thing. Whatever the x value is, you're going to substitute it into the original function. The y-intercept is an ordered pair, and you must write it as an ordered pair. Now, think about this logically. If you're passing through the y-axis, anywhere through the y-axis, the value of x always is 0. So the y-intercept is 0, c. So all we do is substitute a 0 into the function and calculate it. But look here. This is ax squared plus bx plus c. If I put zeros in here, it doesn't matter what's going on here. That's going to be 0, that's going to be 0, and you're going to be left with negative 3. So it is the c value, that constant on the end of your function, as long as it's in standard form. All right. Example 2 says graph and label the vertex and the AOS. All right, so we're going to go through and do this problem. So I will say you have to first make sure it's in standard form, and it is. We're going to identify what A, B, and C are because we need that. Remember, for these, you have to find the vertex a different way. This is y equals ax squared plus bx plus c. All right, does this thing open up or down? Well, the a value, the leading coefficient, is negative. So number 1, this opens down. Number 2, I need the starting point, and the starting point is called the vertex. The vertex is the ordered pair, negative b over 2a, comma, and then we have to find f of negative b over 2a. Remember, this is f of x, and f of x takes the place of y. So this really is still an ordered pair, x, comma, y. Okay, but we have to use negative b over 2a to find our x. All right, well, let's do that. X equals negative b over 2a. What's our b value? Negative 2, right? It lines up. What's our a value? Our a value is negative 1/3. This is a good example. It's forcing us to work with fractions. The opposite of negative 2 is positive 2. 2 times 1/3 is 2/3, and it's negative. Folks, you got to multiply by the reciprocal. You know, this really means 2 over 1 multiplied with the flip of this, okay? Because this is really 2 over 1 divided by negative 2/3. We change the division to multiplication and invert the divisor. So this is times negative 3/2. All right, the 2's are going to divide out, and I see that my x value is negative 3. That's the x value of the vertex. Now I have to find the y. So I'm going to find, excuse me, f of negative 3. All right, so to find f of negative 3, I'm going to go back into the original function. Negative 1/3 x squared, subtract 2x, subtract 3. Notice how I'm leaving parentheses so that I don't make any sign errors. So I'm putting negative 3 in there and negative 3 here. All right, I have to square the negative 3. When you square negative, it's always positive. So this number is 9. And 9 divided by 3 is 3, times negative 1 is still negative 3. This value is negative 3. Look here, 2 times 3 is 6, but they're both negative, so this is plus 6 and then minus 3. So my y is negative 3 plus 6 is 3 minus 3 is 0. Which means my vertex is the ordered pair negative 3, 0. So I'm going to plot that. X is negative 1, 2, 3. Y is 0. This thing opens down, so it should be going like this. All right. 3, I need my AOS. AOS is the equation x equals negative 3. So I'm going to draw my vertical line, my axis of symmetry. I'm going to label it x equals negative 3. Let's find the y-intercept. When you're finding the y-intercept, you're really finding f of 0, right? Because the x value is 0 when the point is on the y-axis. So if I put a 0 in for these x's, everything goes away. My y-intercept is going to be x is 0, y is negative 3. So I go x is 0, y is negative 3. We need to find one more point because for these graphs, you need 5 points on your parabolas. 5. Find another point. You choose the x value. You don't have to make a big table. Because we already found our vertex, we already found this point. We can use the axis of symmetry to find, if this is point P, we can find P prime by using the axis of symmetry. This one is 3 units to the right. I would go 3 units to the left. There it is. That's P prime. I'm going to want to choose an x value that's farther to the right than this, so bigger than 0. It might be a little big, so I don't know. Maybe pick a value between these 2 points. So let's go with negative 1. Let's find f of negative 1. All right, so I'm going to do negative 1/3 times negative 1 squared. Remember, I'm using the original equation, which is back up here at the top. Okay, negative 1/3. I'm putting a negative 1 in to square it. Subtract 2 times negative 1. And then I'm going to subtract 3. Okay, so I'm filling this in. Here is my y equals ax squared plus bx plus c. I'm substituting the -1 because I want to know what is the y value when the x is -1. So now I have to compute this. This becomes y equals, all right, this is +1 when I square it, times -1/3 is -1/3. This multiplication of -2 and -1 is +2. And then I have a -3 on the end. So I see that my y value is -4/3. Because look at this. 2 minus 3 is -1, and -1, or -1/3 minus 1 is -4/3. So the ordered pair there is -1, x is -1, y is -4/3. All right, so I'm going to plot that. X is -1, y is -4/3, which is -1 1/3. So I'm going to call that point Q. 2 units to the right means 2 units to the left for Q prime. And now I'm going to connect my points with a smooth curve. And this is how you graph the parabolas of the form y equals ax squared plus bx plus c. If you don't have a middle term, then you have to make a table. So if you have any questions, post a comment on the homework discussion or come into a Google Meet. You know, you could label your vertex on the actual graph if you wanted to. We should talk about a max and a min, though. This thing, does this have a max or a min? It has a max. The max is happening at what x value? -1. The max value, oh, not -1, -3, sorry. Right, because this is the maximum point. The x value there is -3. The max value is 0. That's the y. Okay, and this should match the vertex, okay, because that's what we're talking about. We're talking about that vertex point. So the max happens at -3, and the max value is 0. So again, if you have any questions, post a comment. If you need more examples, I could do another quick short video. But this is just all about organization. I don't think it's difficult. You just have to practice them so that you can get the hang of it. And, you know, if you don't practice it, you won't learn it. Okay. Have a great day.